Hello everyone and welcome to another amazing session in which we're gonna see how to work with weights and biases and integrate it with our already existing TensorFlow code base. Weights and biases help practitioners in experiment tracking, collaborative reports, dataset and model versioning, interactive data visualization, and hyperparameter optimization. It's trusted by over 100,000 plus machine learning practitioners around the world. In this session, we are going to focus on experiment tracking. Don't forget to subscribe and hit that notification button so you never miss amazing content like this. It's one thing to build a model, train this model, and evaluate it on a given data set. And at least as we've seen throughout this course, this is pretty easy with TensorFlow. But when we're working in large teams and we have to collaborate, we have to produce reproducible results. We need to debug these ML models as a team, and we also need to enforce transparency. Then a machine learning operations platform like weights and biases becomes indispensable. Weights and biases permits us build better models faster with experiment tracking, data versioning, and model management. As of now, the different products which weights and biases offers to us are experiment tracking, reporting, that's producing collaborative dashboards, artifacts, dataset and model versioning, just like how you would do code versioning in Git, interactive data visualization, and hyperparameter optimization. Now also, you could see here that this is being used by modern 100,000 machine learning practitioners around the world. Some key aspects of this weights and bias tool are the fact that you could integrate very quickly. You see that with Keras. So here we're supposing we are building a Keras model, a TensorFlow Keras model, and that all you need to do is to import this WandB callback right here, start a new run as is given here. If you have some configurations, you set that those configurations, and then in the place of the callbacks, you simply pass this weights and bias callback, which we imported right here. So it's quite easy to integrate with already existing frameworks. Now you see with any framework, you just need to do wandb.log and you could log any information you want to log. We could also visualize useful information very seamlessly, and then we could collaborate in real time. So here, if you're working on a project, you could all, as part of the team, discuss the project's progression and see how to eliminate any bugs or any problems. Now, weights and biases is designed for all use cases. So here we have a practitioner that's, we're supposing just a single person. You have this dashboard, central dashboard. You can look at, you see this hyperparameter sweeps, artifacts. Here you could do dataset and model versioning, just like you would do with GitHub code. Reports to share updates very transparently. Throughout this course, we'll look at these different products, and in this section, we'll focus on experiment tracking. We're now going to go straight forward into signing up. So we click right here. We want to sign up with GitHub, click here, and then we authorize WandB to get access to our NeuralLearn account. So authorize WandB. We have the full name, organization, NeuralLearn, and that's fine. Okay, so I agree to the terms and conditions. You could always read out those terms and conditions very carefully, and then from here we also have to put in this username. So let's say NeuralLearn, and okay, so we continue. How often do you train models? Let's say every week. So we have that, and then get started. Here's now a home page. Here you could create a new project. You could modify a profile, invite your team. You have this documentation. You click right here, docs.wandb.ai with the different guides, references, which you could always make use of in case you are having any difficulties, or as a starter you want to master how all this work. Then you also have this fully connected right here, which brings ML practitioners together. Now here you have curated tutorials, conversations with industry leaders, deep dives into newest ML research, and a whole lot more. So you would always have this information or this curated information at your disposal. Then we also have the community, and then we have this quick stat for the different frameworks. So we could view all frameworks here. Getting back, you see we have PyTorch Keras. We're working with Keras. Click on Keras. You would have this quick start for Keras users, which we actually. So here you see how easy it is to get started with WandB in Keras. The very first step we'll take would be to install and log into WandB. So we'll simply copy this and then get back to our Colab notebook. We paste this out right here and then run this cell. We have the syntax error. Let's have this and then rerun. There we go. As you can see, WandB has been installed. From here, we are going to get into the login. Now you see you can find your API key in your browser here. So we could click on this link, get the API key, and then paste it out here. Now let's get back to this and then copy out this API key. There we go. We have that, and then we paste it out here. So we paste it out there, or you could click on this link and then still get the key, which we can paste in here, and then simply press on enter. So we hit enter and we should be able to log in since we have this key put in right here. Now moving on to the next step, at the top of your training script, start a new run. And to start this new run, we're going to make use of this init method. Getting back to the documentation, you have your run is a unit of computation logged by WandB. Typically, this is an ML experiment. So we create a run with the WandB init. So before moving on, you should note that you could create a project, and in this project you have several runs. Now one run could be for training, so we could have a training run, like some sort of ML experiment as defined here, and then we have evaluation, and you could have other different runs or other different training processes which will act as different runs. Here, as you can see, when you just import WandB, the run is known, and now you have WandB init. Once you make a call with this, on this method, you have a run which is automatically created, and so everything you're gonna log in into WandB would be sent to that particular run. So if you have, say, this project, let's call this project malaria prediction project. If you have our malaria prediction project, and then we have this training run, everything, like once we create this run, everything we log in will be sent into this particular run right here. And then if we create another run, that's evaluation run, everything we log in will be stored in this particular run here. So getting back here, you see you could create this run and you could finish, or you could stop that run. And that's why, yeah, once you have this init, you've created a run, you stop the run, and then here normally this should be known, that there should be no run going, no run created. Now after doing this, you could also create this, like here, like WandB.init. You could put this in a with block. So we have with WandB init as run, then you now have all the data to be logged in here, such that out of this with block you have no run. From here you could check out on the different attributes and then the information related to these attributes. Now let's get into this WandB init. WandB init, you have its definition with all the different arguments it takes, and then you have this information concerning all these different arguments. So here we could define, like we have this run which we could create by simply doing WandB init, and then we'll specify the project, specify the entity, like we could say neural learn, the project malaria detection, the configuration, all information we'll be needing, let's say for training. We'll specify save code to permit WandB save our code. By default, this is actually false. So by default, your code is not going to be saved to WandB. You could check this out here. Let's have save code. Let's search that. Save code. Go up, and there we go. So by default, we don't allow this. And you could flip this behavior by going to the settings page. Now you could check on all these other arguments. You have this job type argument too, which is also very, very important. And this is very useful when you're grouping runs together into larger experiments using this group argument right here. Now that said, let's copy this part of this code and then get back to our notebook. We'll notice that we have this imports, so we would have to finish put out this imports here. Let's have this. We have import WandB from WandB keras, import WandB callback. Let's take this off. So we put those two here, and then we run the cell. That should be fine. Now that's run. We scroll down. We have the model. Let's run this again, and then let's actually get back here and create this run. So let's have this here. So WandB init, we're going to specify the project. We're going to create this. So this is WandB install login and install login and initialization. So we have that. Now, as we've said already, this is going to permit us create a run. So here, let's have malaria detection. And one way the like to write this out, like prefer to put this hyphen instead of the space. So let's have that way. So we have here malaria detection, entity neural learn, and let's have that for now. So let's run the cell, and then let's add this code below here. Currently logged in as neural learn, and that's fine. From here, let's now do WandB.run and see what we get. From here, we see that we have no metrics logged yet, so that's fine. We could now take this off and then go straight away to add our WandB callback to TensorFlow. Before that, we have save model inputs and hyperparameters. So WandB config, let's have this copied, and then we have that before defining the model. Let's copy that, and then just here we'll add this code cell again, and then let's have your initialization configuration, and there we go. Okay, so we have that WandB config, learning rate specified, number of epochs, batch size would include the dropout rate, the image size, regularization rate, number of filters, kernel size, number of strides, pool size, number of outputs for the first dense layer, number of outputs for the second dense layer. Was that fine? We now run the cell. So we've now started this configurations. Then the next and last step is to simply have this callback in this fit method. So let's copy this out and then get back. So we have that. We've run our model. Let's be sure we've run this model. And just here, let's have this configuration. Let's say we have our configuration equal WandB.config. And then right here, we have configuration and im size. And we have same for the other hyperparameters like the dropout rate, regularization rate, number of filters, kernel size, pool size, and number of strides. We now go ahead to the training process, and so we copy this out and paste just right here. So here we would have this callbacks. Let's take this off. Instead of this Tensorboard callback we now have this WandB callback. So we have this WandB callback, and you could always even include the Tensorboard callback. So you could also have the Tensorboard callback we had previously. Now there we go. We have this WandB callback. Let's have that. And then we run the cell for metrics. We compile the model. Once the model is compiled, let's include this learning rate. So let's have this configuration, and then we'll specify the learning rate. So we have that learning rate there, and then we compile the model and start with the training. Now the training is complete. We could go to our weights and bias dashboard right here and see exactly what went on during the training process. So here we have this projects. You could see here neural learn. We have the projects. We click on this malaria prediction project, and then we select this run. The run we select in here is this sandy water run. So there we go. Now you see we have 19 different chats. AUC, validation loss, false positive, false positive. Well, this is epoch versus epoch, so that's why you have this kind of straight line. And then you have this precision, recall, loss, true negative, true positive, accuracy. In fact, all this is basically gotten from all this metrics we had here. So this means that with this simple callback we have put right here, weights and biases is able to get all this or capture all this information during the training process and give it to us or present it to us after we're done with the training. So here we can see those different charts. We're already used to seeing this already, so you should be already familiar with this different charts. Now, apart from these charts, you have the system information. So here we have the CPU utilization, we have the system memory utilization, process memory in use, process memory in use. While this is in megabytes, here we have this information in the percentage with respect to the total memory available. Then here we have process memory available, process CPU threads in use, disk utilization, network traffic, GPU utilization, GPU temperature. So you could have this information here, GPU time spent, GPU memory allocated, GPU power usage. And so you see how easy it is to get all this system information without writing any extra line of code. Now from here we could go on to the model. You see we have this table right here which shows our model. It's kind of similar to the model summary we had put out previously. So yeah, it's kind of similar to what we had here. So now we have, instead of that, we have this beautiful table right here: output shape, number of parameters, type, and the name. So that's it. And then from here we have this logs. So we have everything that was logged out, like all we had here. So you see everything logged out, we have it in this run. Now recall that when doing this WandB init last year, once we do this WandB init, we actually create a run, and once that run is created, everything we do after that is going to be stored in that run. And that's why if you notice here, like, you don't only have this information, like not only this training information, but even this data which was logged, even this model, because we ran this several times. So you see here that even this information which was logged is actually stored by WandB. And so you see that experiment tracking here is done very easily and actually seamlessly. Now you look at the files we stored. You have the model best. See, you have automatically this Keras model file which is stored. You have this metadata. You could open this up and you have this information stored. You see here that we're using a Tesla P100 GPU. So that's it. Python version, operating system version, and then other information like the GPU count, CPU count, and so on and so forth. So that's it. Let's get back to this overview. You see it's still running. That's because we have our Colab notebook still running right here. Now, one thing you could always count on is this documentation right here. So you just come straight to this integration and then you pick out Keras. You would have here Keras, and then you have this WandB Keras WandB callback. Then right here you have this. Now you could see this arguments, or those different arguments we have here, and you have the explicit definitions here. So let's check out on this arguments. You see we have monitor, the validation loss, which plays a similar role to this model checkpoint callback right here. And also we could specify the mode. So let's get back to the documentation where we are. Okay, so we get back to this mode. So you could pick out the mode. By default it's automatic. We could also select mean or max. In the case of validation loss, obviously we would select a mean. And in the case of if we are dealing with a validation accuracy or validation precision or recall, then we'll select the mode to max, such that we're saving our model when we have the maximum precision or maximum recall, for example. Here we have the save model, save graph, save weights only, log weights, gradients, training data, validation data. Now you should know that with this we're able to pass in our data set to WandB, and the fact that we pass in this data to WandB can permit us come up with some visualizations of what the model is predicting, since now we have the data. Then we also have the generator, validation steps, labels, predictions, input type, and so on and so forth. So you could always check out on this. Now the next thing we'll be doing is take the validation data, pass into this WandB callback right here, and then be able to visualize the different predictions as we go through the training process. So let's break this up a little. We have this training validation, number of epochs. This should actually be configuration, number of epochs, Okay, so we have that. And then we have the verbosity callbacks. Now in this WandB callback right here, we have validation data, which is our val data set. And then from here, let's check out on the documentation. And then we have the labels and the data type. So let's specify the labels. From here we have labels, and the labels we have here, we have parasitized and uninfected. Anyway, we could create this, like we could have the classes, so we could have here labels and then specify this. So let's just take this off from here, cut that, and then paste it out here. Okay, so we have that, and then let's have this labels. Now we have the label. We could also specify the data type. So that said, we specify this to be image. Okay, we have that, number of epochs and all of that. Let's go ahead and modify this number of epochs here. So number of epochs 100. Let's change this. Let's just have 3 epochs for now. So let's get back. WandB config. We should have this up here. So once we make this, we get this new configuration. So we run that, looks fine. We get back to the training. From here now, we could run this training again. Training complete. Let's go ahead and check out on what has been logged in our dashboard. So let's have this here. We pick out this run. There we go. We see we have still our 19 different charts, and then we have this media which has been added here. We click on this and you see what we get. As we could see here, we have the different images and the predictions. You could view full screen mode by doing this. And then just here, you could select the step. So if you pull this to the end, you see we have 36 steps, meaning we have trained for over 36 different epochs. Now, selecting this malaria detection project and having all these 3 different runs right here, you see you could view all the runs simultaneously. So I could click on this one. You have, this is one run actually, this is another run, so I could view all this now simultaneously right here. See, we have that. You see the difference in GPU power usage with these 2 different runs. That's the sandy water to run and this exalted night to rerun. And then from here, if you want to stop a run, if you want to stop this current exalted night to rerun, what we could do is come right here. That is, let's have this code here. We could come right here and just simply put out WandB.finish. So we call this, and we should be able to stop this, the current run. You can always check out on this WandB.run documentation right here to get more information about this. You see here this example given where the create the run and then stop the run, and then this shows that there is no current run, and then after recreating the run, you see that there is now a run. So this is simply how we could stop this run, and that's what we've just done here. We could simply run the cell, And after running the cell, you have this run summary. You see the accuracy and the other different metrics and loss values. Notice how the different metrics and losses are being put out in this command line formatting. So you could see how this loss, for example, your drops. And then getting back to our dashboard, we see that there is no current run. Then we've again recreated a new run with a WandB init right here. So we've created this new run on this elevator. We could check it out here. You see, we created this new run. You can see this little green circle right here. Coming back to the notebook, we have this WandB callback, which we've used so far in logging information into weights and biases. But then this is limited because we are not yet able to define our own custom callbacks. Now that said, let's get back to this callbacks we have defined here. Here we have this log images callback. We're going to actually try to log images into weights and biases using this callback which we had created. Now recall that to create this kind of custom callbacks, you inherit from the callback class in TensorFlow, and then you get to put in some code in here which defines that custom callback. Now we've just copied this and pasted right here, but the difference here is this is WandB. So this is what we had for Tensorboard, and this one now for WandB. We're gonna see how easy it is, even though we're building this custom callbacks. So right here, so let's suppose we want to predict, or rather we want to log this confusion matrices, and we want to log this to weights and biases. Now what we'll do is we're gonna take off all this here. So let's get back. This is what we did with Tensorboard. We saw that we had to make use of matplotlib and then log this information into Tensorboard. But here, what we have, or what we need to do to log the confusion metrics, is simply just this part, this code right here. So here, what we have is we'll take all this off. You see, we take all this code right here off. Take this off. Let's have that. So we have this code right here taken off, and then we just left with this. So you see that instead of having to write all this code, all we need now to write is just this one. Now, if you're wondering why how to get the other plots, or what other plots we could get automatically like this with weights and bias, we get into this weights and bias GitHub repository, and here we have via this link, WandB client tree master WandB plot. You see all the different plots we have now, and since it's constantly under development, surely in some time to come we will have many more of this different plots we could do very easily. So here we have bar.py confusion metrics. You see we have the confusion metrics, histogram, line series, precision recall curve, ROC curve, and scatter py. So this means that already we could plot out this confusion metrics and the ROC curve very easily with weights and bias. So let's get back to this. We'll check this out. First thing we have to notice is log WandB.log. So whenever you're using this WandB callback here, what's actually happened, what happens under the hood is this information has been logged like this. So we make use of this WandB log, and then here we are gonna have, let's change this, let's say confusion metrics, and let's write like this. Okay, here we have the confusion metrics, and then you have WandB plot confusion metrics. You could modify this and put PR curve, that's precision recall curve, or ROC curve, and that's it. And then this props, then we have y true, preds, the predictions, and then the class names. So here we should change this class names and have parasitized, and what do we have here? We have uninfected. And then you can either pass the probabilities or this predicted score. So here we are gonna have props equal predicted, since what our model predicts or what our model outputs are these probabilities, and then the while true is equal labels. From here we're gonna take out the spreads because we've done that already. So let's have this here. There we go. This doesn't take into consideration the threshold, so we'll take off this threshold. That's it. Now we have this callback WandB, and then we're ready to train our model. After the training process, we have this results which look great, and we could now go ahead to look at the confusion matrix plotted in the dashboard. So let's get to our dashboard, and this is what we should have. Let's get back to runs and then click on this current run, and this is what we get. Now we see that we have this confusion matrix which doesn't actually show us what we expect to get, and this is simply because the way this was conceived, or the way this callback here, this login was conceived, was such that we have a multi-class problem. So even in the case where we have a binary classification problem, like in this case, we expect to have an output of 2 values. So that's why when you have this output, let's get down here, let's click on this, let's add this code. So that's why when you have the value like say in the output 0.9, it's considered to be parasitized, although we defined already that parasitized is meant to be 0 uninfected equal 1. And so when we have 0.9, this is greater than the midpoint of this 2, which is 0.5. So we should consider this as uninfected. But the way, as we've said already, the way this has been conceived is such that even in the binary classification problem, we shouldn't, or we don't have a single output, but 2 outputs. That is, if we have a value of 0.9, what WandB expects to see is something like this, something like 0 and 0.9. So showing that here, or let's even put here 0.1, even 0. Let's say 0.8 and 0.2. Okay, so let's have this. So even in this case, it comes back to the same output. So this simply means that we are having an uninfected cell, since this first index here has a higher value. Now to solve this issue, what we're going to do is we're going to take each and every output we have and convert it to this format. So in the case where we have, for example, 0.1 as output, we're going to convert it into 1, 0, because this means that the higher, or this one means that it's parasitized cell, and this 2 means the same, because here we're saying that this 0th index, which is the parasitized index, has a higher value, hence this is a parasitized cell. So that said, what we're gonna do now is for all values less than 0.5, we could say less than 0.5, we are gonna convert it into 0. Sorry, we're gonna convert it into 1, 0, and then for all values greater than 0.5, we're gonna convert them into 0, 1. So this is the transformation we're gonna make in order for this WandB log method to correctly log our values. But note that if we're having a multi-classification problem, it will be needless doing this transformation. So let's get straight away and see how we're going to transform this into this required format right here. Let's start by copying out this first part. Let's copy this into this other cell here. And once we run this, we have this output right here. Then we could go ahead and modify this predicted. So what we now have is we will define the spread, this other list, and then for I in range, the length of predicted, we are gonna make sure that if the value predicted I, we're gonna take this 0th index. If it's less than 0.5, then what we have to do is append this to this list spread right here. So what we're gonna append is 1, 0, because this is less than 0.5. So if it was a multi-class problem, we would have the highest or the higher value in this case. Since we just having 2 classes, we have the higher value representing this output which was predicted, which happens to be less than 0.5. So we have here 1, and then here we would have else spread append. What do we have next? We have 0 1. So here we have 0 1. Let's take this off, 0 1, and that's fine. So here we've modified the spread, and then we could then print out the pred. So with this now, we should be able to have the expected output. There we go, we have this output. Let's add this code cell and then print out our pred shape. We run this, and what do we get? You see, we have exactly what we expect. So that's it. Let's copy out this part from here, and then we're gonna add this here. So we have this pred now. Let's have this forward, and then we're gonna have pred equal np.array of pred. So we'll convert it into a numpy array before passing into this log method. Console, that should be fine. Okay, so that's it. Now we have this set, everything looks fine. Let's take this off and have that pred. So we have this pred now, everything looks okay, and we could now rerun or restart our training. So let's have this here. Let's take this off. From here we train again for just about 2 epochs, and then here are the results we get. So you can click on this run here, and then you could have the tables and the custom chats. Let's start with the custom chats. You could expand this way. So here you see that we have the predicted and the actual. So we have the model. You see now that we have this number of true, let's say true positives, which increases, and number of true negatives, which also increase, while we have this number of false negatives to be 112, while here we have 62. This is 1278, 1305. And when you compare this with this previous run, you see that now we're having reasonable outputs. As with this previous run, we had that error where the confusion matrix method of WandB considers all the outputs to be parasitized. Let's have this back and take this off. Then from here we could go ahead and to look at how to plot the ROC plots. Let's get back here, scroll up. What we'll do is here we just have to, let's comment this here, and then now do the same for the ROC plots. Let's get back to the GitHub repo and click on this ROC curve here. In this here we have now these arguments which have been described. So here we have y true, y probabilities. Obviously this is the label predicted, and then the classes, the class names, classes to plot. That is a set of classes which we are gonna plot, or we're gonna exclude all classes which aren't specified in this classes to plot argument. Now this is actually optional, so you don't necessarily need to have this. We also have this title. So let's copy this out. Let's copy out this here. Let's copy this out and paste just right here. We then specify the labels, y true labels. Here we have pred, and then right here we have this class names. So let's copy this out and paste here. Okay, so that's what we have. Let's run the cell. Everything looks fine, and then restart with the training. Training now complete. Here are the results we obtained. We get back to our dashboard, and this is what we have. You could go back to the runs, and you'll see that you click on this custom chart right here. No, let's click on this run here first, and then we have this 2 custom charts. So we have this previous confusion matrix which we logged in, and then now we have this ROC curve which we just plotted out. We could also check out the tables for the ROC curve and the confusion matrix. So here we go, we have this ROC plot, and then we have those 2 plots here, where one is for the uninfected and the other is for the parasitized class. I haven't seen how to plot the confusion matrix and the ROC curve. We could check out the documentation and look at the other plots. So here we have basic charts, line scatter, bar chart, histogram, multi-line, and the next model evaluation charts like what we've just done, the confusion metrics, ROC curves, PR curves, that's precision recall curves. You have them here. Interactive custom charts, matplotlib and plotlib. So this means you could actually come up with your own plot with matplotlib and then log that to WandB. And then apart from this method in which we use the WandB callback here, no, not this one, the WandB callback we had defined previously. That's apart from using that WandB callback to log the loss, metrics, and other information, we could directly just do WandB.log, and then we say, for example, we want to log the loss, so we just put out loss, and then since we got the loss from this logs, we have this logs here, we scroll down and then we put out here logs, and then we specify the loss. So this all what it suffices to log this loss values. From here you could also log the accuracy and other metrics. This is actually a dictionary, so let's have that. And there we go. So we've seen how to log these values. Now let's also see how to log images. Like with this, we have this image, and then we log this to Tensorboard. Now we'll see how to get this image and then log it to WandB. To log those images, we'll then check out here on the documentation, and you'll see that you could log rich media files. That's really any kind of media file, 3D point clouds, molecules, HTML, and histograms. So that said, you'll scroll down and you have this code here which permits us log image data. So here's logging arrays as images, logging PIL images, logging images from files, image overlays, segmentation masks, bounding boxes, and so on and so forth. So you have this, you also have this histograms, you have 3D visualizations, as you could see, point cloud, and molecules. So you see that WandB actually permits just any practitioner be able to log any data or any kind of data they really want to log, hence making them more efficient. So that said, let's get back to this here. We log in arrays. Let's copy this out. Let's click here. You just simply copy that way, and then you get back to the code. So here, what we're saying is we want to be able to log these images at this level. So let's paste this out somewhere here, and then copy out this part again. We're gonna copy this part. Recall that with this WandB we had defined here, we kind of like we ended at this level where we got the labels and the predicted, and automatically we got this ROC curve and confusion metrics. Now what we want to do is get right up to this point where we actually have the image, that is our own image which we've created, and then from this image log it to WandB. And so right here we have this piece of code here, and we're gonna integrate this. One thing we could do again, let's copy this again. No, let's copy this other one, because here we have the image, so we'll copy this again. We consider that this is for Tensorboard. Let's write here Tensorboard. Okay, we have that for Tensorboard. We have this for WandB. Now WandB plot, and then this next one is just WandB. Let's add this here. There we go. Okay, so here we have this WandB. That's fine. So what we're saying is we're gonna take off all this here. So we take all this off, and then we copy this out, or let's cut that out, and then paste it here. So there's how we're gonna log this to WandB. As usual, it's gonna always be simpler than what we have with the Tensorboard. So just all we need to do here is just to take our image and then log, as simple as that. Now our image array here, let's say this is our image array. Our image array is this output which we have, and then we pass this image array into this caption. Let's put a caption, let's say confusion metrics for epoch, and then we get the epoch from here. Like we have this epoch, so we're gonna be logging this confusion metrics for each and every epoch. So we just put out this epoch here, and that's fine. So yeah, that's our caption. We have our WandB image, and we log it in here. let's have this, let's say confusion metrics, or yeah, confusion metrics. Okay, let's have that. Now we run this, we copy, anyway we had that already. Let's copy this out. We having an error here, they should be closed. Okay, so that's fine. We have this WandB log right here and everything looks okay. Okay, so let's run that again and check this out. Looks fine. Now we could go ahead and start with the training. Let's run this. This should be okay now. And compile the model. After compiling the model, we now go ahead and train the model. Let's say we want to have 3 here. Let's keep that aside for now. And then here we have this. Let's paste it out. It should be the same. Okay, here we have it. Now let's run the training process and see what we get. Training now complete. We can get back to our dashboard and see what we have as plots. We'll click on this here, this run, our current run. We have this image we locked previously. Now let's check in this hidden panels and see what we get. And it happens that we have this confusion metrics locked in this hidden panels. Anyways, we have that. And what do you notice? You see for the 3 different epochs, you see for the 3, you could go to the second and then go to the third epoch. Start with the first. You see we have the confusion matrices which have been logged per epoch. And now let's do this so it appears clearer. And we see we have this number of true positives, true negatives, false positives, false negatives, and so on and so forth. So that's it. From here you can notice how this value leaves from 68 to 52, and then finally we have 53. Now another interesting functionality here is you could simply have that. See, you could download it and now you have this full screen and you can see that clearly. So let's press escape, close, and then get back. So that's it. That's how we log this image very easily with WandB. Now getting back to the documentation, you might have noticed that you have your Keras and then you have TensorFlow somewhere around. Okay, you have TensorFlow. You see that these are kind of like considered to be 2 separate libraries. But then just note that if you build in Keras model, that's if you build in this kind of model where you have you're making use of this method, this fit method to train your model, then making use of this Keras documentation right here is appropriate. But then sometimes you want to have control or full control over what you're doing, and then you want to be able to do custom training like we had seen previously. Let's scroll down. Okay, custom training loop. So if you're having a custom training loop like with this here, you would find that you would not be able to use the WandB callback as easily as you had done with the Keras code. So in that case, you'll see that instead of having, like, for example, like here we have training block and then we have this loss. Here all you need to do is come and put in the WandB, you log, and then you log the loss. So here you just say loss and then you simply log this loss, let's say loss numpy, and that's all. So this is what it takes now to log this loss values, the different metrics, and so on and so forth. The integration with Tensorboard has been made quite easy too. So if you're already using Tensorboard, it's easy to integrate with WandB. Now here they say how WandB is different from Tensorboard. The ability to reproduce models, automatic organization, fast flexible integration, persistent centralized dashboard, powerful tables, and tools for collaboration. That said, let's copy this out. Let's copy this again. And now when we'll be creating our run with the init method, we're gonna instead have this. So let's get back to our code. Let's reduce this here and then stop this run. So we have this WandB finish. We stop the run stopped. And then we're gonna create this other new run, which will take into consideration our Tensorboard logs. So let's get back to the top and just right here we'll paste this out. We've already had this, so we could take this off. Now let's comment this and then let's have project entity, just copy that and paste out here. That's fine. Configuration, we have that, sync Tensorboard, that's fine. Okay, let's run this now. We get this error, so let's take this off here. Now this isn't compatible with version 2 of TensorFlow, which is what we're using. So let's run this again, and this now should be fine. We now have created this new run. Let's scroll down and we get to our custom training loop. So we're gonna run this. We have the optimizer, metric validation, epochs number specified, and then let's say we have this as configuration, and then we have an epochs. Okay, so that's it. We have all this set, and then we run this. We've seen this already under the section on Tensorboard. We get this warning when using several event log directories, like what we're doing right here. Please call WandB Tensorboard patch and then specify the root log directory before the WandB init. So let's take this from here, copy this out, and even if you check in the documentation, you should have that. So here you have this here, the WandB Tensorboard patch, and then you have this root directory right here. So this means again we're gonna stop the current run. Where are we exactly? Let's stop this current run. It should be at the level of training. We're gonna stop this current run here. We run this again, we stop that run, and then what we do now is we have this here, and then we specify logs. So we have that root directory specified. Now we have the root directory specified, that's logs. Get back documentation, we have that specified before the init, so we have to run that before the init. Looks fine. Let's run this now. Let's run the cell, and there we go. Yeah, we told Tensorboard already patched, remove the sync Tensorboard true from WandB init. So since we've already done this patch, we should remove this from WandB init. Okay, let's take that off and run again. We're still getting the error, so what we'll do is we just get back and then have that, and then we'll just go as we started initially. So let's run this. This should work now. From here we're gonna continue with what we're about to do with the custom training process. So let's scroll down. Okay, so we are gotten to this point. We have to, anyway, we've run this already, so that's fine. Now we could comment this one and then run the cells, run this neural learn method, and then start the training process. As you can see, training now complete. Let's go ahead and launch Tensorboard. We have the loss values and accuracy values which have been logged in. You can see them here. Let's reduce this validation accuracy and the validation loss. Now from this, we're now going to look at our WandB logs. So we click on this run, and you see we have this logged data in here. You see we have the train, we have the plot for the loss, we have the plot for the accuracy, and we have the plot for the global step. Then for the validation, you see we have this here, we have the global step, validation loss, and validation accuracy. Exactly what we have with Tensorboard without adding any extra line of code for the WandB. That is the only thing we actually did was at this point here, we said we wanted to sync Tensorboard. So this is all we need to sync Tensorboard with WandB. So if you have been using Tensorboard, or if you are using Tensorboard on a particular project, that's all you need to log your information now to WandB. Apart from this, you'll notice this Tensorboard here. So you can click on that. We're spinning up your Tensorboard instance. Hang tight, take about 30 seconds, and we'll keep it online as long. Before even completing the sentence, you have this already. So you see we have this Tensorboard which has been logged here. We have this PyTorch profiler, and then time series, scalars, just exactly what we have with Tensorboard. So that sounds cool. We have the logs, we have the different files which have been saved, system information, and we have this charts, and then overview where we could see all this information, and then get back to our runs. So that's it. We've seen how to sync Tensorboard with WandB, and so now you're ready to track your experiments with WandB. Thank you for getting right up to this point, and see you next time.